say definitely join the mailing list, get involved with the community. Start with Puppet Enterprise. There's a free demo available, and it really makes it easy to get going. Read the documentation, and don't be prepared to, have to spend a little bit of time getting going, but start small. Pick a small win, get a small win. Factor just starts working out of the box, and that is something everybody loves, being able to just get all that rich inventory detail back about your environment. I've not seen anyone who doesn't think that's an immediate win.
My advice for somebody just starting on Puppet would be to find some small problem that really bothers you and focus on that first. It could be something that happens to you every day that you need to take care of, or just something that happens once in a while, but it's really painful. Find that problem and solve it. And when you have a solution for it that works, even if it's not perfect, get it out there. If you don't get it out there, you're going to spend all your time trying to be perfect, trying to make a better patch, make a better fix, and you're never actually going to use it.
I definitely recommend anybody deploying Puppet Enterprise to deploy version control system like Git, so that you can use Puppet support for Git with R10K synchronizing against individual code branches to get multiple environments. That enables you to develop your code in one environment, test it in another, and then deploy it in your production environment. Take the time to do proper capacity management. Spend time thinking about what your development and deployment workflow are going to be. You have to use R10K. If you're going to start, if you haven't used Puppet before and you have no Puppet environment today, and you decide you're going to have a Puppet environment tomorrow, use R10K, no question.
The cultural change that has to occur to enable something like Puppet to be successful should not be underestimated. So working first of all to help understand what people are going to be your change agents to help make Puppet successful, helping them get the training, and the rest of your organization get training at varying levels according to your need. And then moving forward to identifying probably a stack or an application stack top to bottom that you can actually use as a poster child for a win in your environment. In parallel to building that entire stack, I would also recommend identifying maybe a baseline config, those things that you can make consistent across your entire environment, and utilize Puppet to drive consistency across a large swath of applications or application stacks. Finally, as you've worked to understand maybe one large application stack and you've seen the business benefit of that, and you've also done a very broad swath across your enterprise and you see the operational benefit of that, you can then plot your future strategic initiatives as your business needs dictate.
Okay, new words. Over your large swath, over your big enterprise, over your API or application stack. Okay, simply saying, morning, Elaine. Simply saying, your application stack, that's a stack that's used through your OSI model for development and DevOps. Okay, the stack is what pretty much they refer to the OSI model as the stack sometimes. The alternative stack, you could have your physical stack, meaning all the core devices that it may have to transfer through in order to interact with another server, making sure that's secure. You can see that as well. So Puppet allows you to do that, and there's something else I wanted to show you too.
You might also train users on what proper security policies might be. And another example of a direct control may be a sign that you put on a door that says authorized personnel only.
And then after we look at Chef,
there might not be a lock on the door, but the sign saying
we'll get back to Charles.
Only directs people to either.
All right, setting up Chef automation involves several steps. It tells you here, preparing your environment, install the necessary things, configure the server. Now, when you have all of this,
policy fits into a managerial category.
It will report back to an IP address. Anytime you set up these things, it will report back to an IP address. What did Charles put in here? What picture is that? So, figure out what operating system you want to work in. Ubuntu, Red Hat, that's RH environment, right? Or CentOS, which is another part of Red Hat. They go together. Host name, you have to set up a fully qualified domain for your domain name for your host, and everything will be transported by secure sockets layer. And you have to use code to set this up. When they're talking about to refine your code, when you set up these monitoring services to report back, That's why when you get into, you need to know a little bit of JavaScript, a little bit of Python. Yep. Who's worked with this before? Leah, Mr. T, Elaine, anybody use coding?
Yeah.
These systems before?
Yeah.
Brian, no?
Yeah, I did.
So you'll have to use a little bit of coding to set this up. Then you will have to deploy it. Now, what we're looking at is for Linux, but however, it's all the same, because if you have to use in a Windows environment, you're still going to use PowerShell. PowerShell is the environment that you would use. Now, specifically, PowerShell is used for user experience. PowerShell ISE, infrastructure environment, IS, infrastructure environment. I did, but just the basics. Okay, but you can understand like what you really need to set it up though, right? So PowerShell ISE, and you'll see this on the exam, so I'm telling you right now, has an extra security layer. PowerShell ISE in an enterprise environment can simply just allow the sysadmin to run code, and you can deny code run for regular users. They can only do basic things like IP config or stuff like that. But if they try to run a shell code, nope. So it's real good.
We want to be sure that the recipient
all right. So if you want to install Chef,
hi, I'm John Tonello, a member of the Chef team. In this video, I'll show you how you can deploy Chef Automate and Chef Infrastructure Server in a virtual machine. The base VM I'm using is Ubuntu 20.04, and I've made sure the server has a fully qualified domain name by editing the etc hostname file. This is important for name resolution between the server, Chef Workstation, and target nodes, which will share a certificate with the full hostname. It's necessary to set a couple system variables before deploying Chef Automate. These commands set the necessary values. Be sure these variables are written to etc syscontrol.com so they persist between reboots. We made it so you can install Chef Automate and Chef Infrastructure Server using Chef itself. Here I'm downloading the latest version of the Chef Automate package and making it executable. Now I run Chef Automate Deploy with the two product flags to install Automate and InfraServer. This will download and install everything and then do a service health check. You can run Chef Automate status at any time to check the status of all services. In order to communicate properly with Chef Workstation in your nodes, I create a new admin user, J. Tonello in this example, and then an organization called Lab. Notice I'm using the admin user as part of the org create command. In addition to creating the user and organization, this command outputs a PEM file. The user.pem file, in this case jtonello.pem, will be copied to my workstation installation to complete the secure integration. When I did the Automate installation, it created an automate credentials.toml file in my home directory. This contains the URL and credentials for logging into the Chef Automate dashboard. I use the admin password combination to log into the dashboard. Navigate to the infrastructure tab.
This means that we can check to
okay, let's take a pause here so we know what we're looking at. When he set it up on Chef, he was using the client installation. Remember we said you have to set up the client to report back to the server? Remember that? So he's setting up the load or the installation of the software in order to take telemetry from the endpoint and send it to a fully qualified domain name or a central IP for the server to collect. Right? Once it joins here, Now, here's the beautiful part. Now you have the dashboard where you can look at everything comes to it. It doesn't have to go look for it. It reports automatically. Now, if you really want to get into like your fast path and getting into cybersecurity, if you take one of these programs and download them for free and get to know it, and you can talk about that in an interview, this is where they need people to know what they're doing. This is where they need. I don't know, Mr. T. Give me your 2 cents and your thoughts, because I know you see this every day. Well, how do you feel about this and where we're at in IT? Your opinion, sir, of how important knowing how to look at dashboards are. What you
I
think?
mean, it depends on experience too. Like, if you know how to automate like certain thing, it would be good for you in the IT field.
Yeah. So he said, Keith, if you know how to look at a dashboard and automate something, I like the way he said that. So it's over several platforms. All right. So let's get back into the video so we can just get past it. Here we go.
And click on the Chef Infra Servers menu. I'll add my integrated server by clicking the Add Chef Infra Server button. Entering a name for my server, its fully qualified domain name, or just automate.local, since automate and the server are on the same host, and then add the IP address. You can see the server has been created, so I click the link and add an organization. I'm naming it the same as the organization I created earlier, Lab in this case, entering the username I created, jtonello in this example, and then pasting the contents of the jtonello.pem key created earlier. Clicking the Add Chef Organization button saves the configuration. That's it. Chef Automate and Chef Infrastructure Server are installed and ready to use. I can now start working with Chef. Hi, I'm John Tonello, a member of the...
Okay, now I will say with this too, the way he set that up, just so you can kind of understand, is he had 2 things. He said local or server. He set it up on the local computer, so some of the free apps you'll see, the free trial ones, they'll have it where you can download it and set it up on the computer you're working on as a trial, and it'll take all the event management stuff just from your computer, so you can see how it populates, parses, and correlates. You get what I'm saying? So it uses your own telemetry to present it in a server look, so you can work with it, play with it, see how it goes, implement rules and stuff like that. If you would like to go to like an enterprise environment where you handle like 20 to 30 devices, it'll allow you to do that. It may now come with a timer, a free version with a timer that could go like 30, 60 days. Or you may have to just pay a small little fee. And what you do is, you could call these people. A lot of these folks are like, hey, I'm an IT administrator for such and such. They may say, hey, email me from a company email so I can verify it's you, because it's got the fully qualified domain name, and I'll send you over a free copy. I don't know how many schools send me stuff saying, hey, can you do this? You want my computer career? We'll set you up for free. Just because I got a fully qualified domain name with my computer career. My computer career. No, I'm good. Right? So that's how you get free trial stuff and free software, and you get to work with the vendors. All right? If you're just starting out in IT, just call them and say, hey, I'm setting up a home lab. I'm actually in cybersecurity, and I'm working with this and this and this. They'll be like, oh, they might have something for you. All right? A beta test or something. So it's different ways you could look at it. Any questions on that so far? I like this stuff. I like looking at the application interfaces. All right, Mr. Charles. All right, so he made it through the round 2 of the interview process, and I like Charles because he lets me razz him a little bit. He keeps it joyful.
Yeah.
He's made it. Is he stuck? Is his screen frozen?
If you perform a hash of the changed data, you'll see that the hash value
It looks like he's frozen, doesn't it? I think he's doing that on purpose to make it look like he's frozen, but he's not actually frozen.
I have downloaded this file
Mr. C.
to perform my own hash, and compare it to the original, I can see
Wow, he is frozen.
something has indeed changed with this particular volume 1 of the group.
How did he do that?
Media. At this point,
Yep.
we might want to
I was like,
again to see if we happen to get
would have waited to evade the second round of interviews. He bailed on us.
To see exactly where the change might be between the
He'll
original
be back.
version of the volume 1 and
But until he gets back, yeah, that's cool. Who thinks they might be interested in working with APIs and dashboards like this? Monitoring stuff. I would think too, Mike, this will be up your alley too.
But we can also add to this an additional
No,
level
not really.
of integrity called proof of
Elaine,
origin.
how you feel about that?
Yeah, I could.
Sent the data to us.
Yeah.
Sometimes you'll see this referred to as
There's another, since we're waiting for Charles,
source of the
we still
message.
got 5 minutes.
By using a digital signature,
Let me show you just one
we
site.
provide non-repudiation. So not only do we know the person that has sent that data to us, but anyone else could examine this transaction and verify that the information we received.
Oh, Charles is back.
Conveniently, my internet decided it wanted to reset itself.
Did you hear us? Well, me, I have to take responsibility for it. So did you hear me talk about you? I was like, is it screen frozen? Did he do that?
I was saying that, I was like, you guys froze.
Yep. I was like, hey. I said, what a way for him to avoid the second round of interviews. He's like, hey.
Yeah.
No, but I was saying thanks for being a good sport. Let me pick with you. Okay, of course. All right, so you made it to the second round, Mr. Charles. I'm interested to hear more about this policies that you can implement. That's why we called you back. So we know you have extensive knowledge. What can you do to help us with configuration drift? I told my friends, they're all here in the room with you. And they're very interested to hear what you got to say too, because they've been trying to figure out that they couldn't.
Well, so based on what your configuration needs are as in regards to apps or content or various settings that you want, we can implement a program like Chef or Puppet to automate updates and control what people are using across the board in order for us to have a very good continuous throughput of what we need, so everyone's on the same page.
Now, we haven't used that. Is it pretty easy to set up? We wanted to do it, but nobody here was like, I don't know. Is it pretty easy to set up?
I've used it once or twice in my life, so I'm not familiar with it, but I have an idea of what I can learn to get to that point, to be able to use it and make things a lot easier.
I like it. Everybody give him a round of applause on that. Give him some finger snaps. There you go. You know, actually, that was a good answer. He pointed out, well, y'all tell him, what was good that he pointed out early on when I asked him, what can you do for me? What did you like about his answer?
And at this point, Bob wants to see if the hash that was in that digital signature matches.
Yep, he can learn to make things better.
So he's going
Willing to learn. He didn't come in saying I'm a pro. What he did say is, I know a little bit about it. This is what we can do. I know that this platform's out here, and it can help you achieve your goal. I've worked with it once or twice, full transparency, but it's nothing to get it set up. We can get it set up, right? Love that. Great. Before we go to break, let's hit up Stigs. Just so you know what it looks like.
This entire process of creating a digital signature
Now I have here
is something that's usually created through
this website.
button on your screen or
Anything you want to know about DoD Cyber. Who's seen this before?
DoD Cyber Exchange.
I think everybody's seen this just a little bit, even if you're doing asset management.
Yeah.
Or if you need to complete your yearly class, cybersecurity training.
Yep.
This is one website you can, Charles like that day cybersecurity training. You can go here and actually, the annuals. You can go here to take the class and download the certificate. So it tells you here, this site contains security technical implementation guides and security requirement guides for the DoD information technology. This guidance bridges the gaps between the national and NIST. Now, please note, on this exam, they're going to be talking about NIST 800 publications. NIST 800. If you ever hear them say, an 800 that's NIST, man. That's NIST. So any answer you give better be a NIST answer. I'm giving peep game now. Peep game. Telling you. It's cheat code. All right. And risk management framework. That's a totally different framework. So the risk management framework. So listen here. The 800-53 risk management framework. If you want to get on the STIG mailing list, you can, but they will verify. They will mail. They try to make sure everybody doesn't have this. But here's the document library when it's talking about STIGs. Okay, now at a certain point, they won't let you do anything if you don't have a CAT card. Know this, okay? Sometimes they'll lock you out of certain stuff unless you present that CAC, Common Access Card. So it talks about Microsoft Defender. This is a new release that came out. Look at this a couple of days ago. Sysadmins and organizations around the DoD need to do this. Let's see if it let me download it. Ain't this a...
Now that we've identified who we are, we now need to determine what type of access we have, and that's done through authorization. If we're part of the shipping and receiving,
here's the overview.
We should have access to systems that should only be available to shipping and receiving, and we should not have access.
Mike's like, why are they letting just anybody download this thing? He has this look on his face, like, how is this possible? Microsoft Defender Antivirus and Security Technical Information Guide. This is what you will have to use out in the real world.
And what time this person logged out. We refer to this entire system as the AAA framework.
The executive summary, what gives you the authority to do this? Vulnerability, severity, category code, definitions. Didn't we just talk about CVSS yesterday? Common vulnerability score and code severity. Distribution, how to comply with it.
Concentrator in the middle. You're on one side of that concentrator.
Let's get past this.
You need to use AAA to gain access.
Then it tells you that DISA has their own category code. The defense agency. Cat 1, Cat 2, Cat 3. So let's get down to the nitty gritty. Send that information over to the VPN concentrator. The concentrator itself doesn't. Okay, talks about the security requirements. What you have to do is a manual review of the Windows Registry Editor, Group Policy Object Editor, and the MMC, the Microsoft Management Code. The emergency paths are defined and tells you need to go in and take a look at them pretty much. I can get from that. And the cool thing is that they walk you through this stuff too.
Matches some type of user in the database. And if the match is
right there, there's a letter of authority, memorandum of distribution. When it talks about Microsoft STIGs and implementation guide. So that's just the verification letter that came out. And as you can see right there,
as a security professional, you'll be responsible for managing the security of
SIG,
or perhaps even thousands
your signing or the signature, electronic signature. So there's actually your private key with the hash is creating your verified signature.
So the question now becomes how,
because it has your information in there about you and your private key.
That's authorized to be on our network.
Right.
This computer by itself, obviously.
So that's pretty dope. As we look at this,
it might be, and in most cases, you probably wouldn't want to store a password on.
You can look at any system, SCAP, SCAP tools, Unix remote scanning plugin. Y'all gotta look at this. Talks about PKI, PKE. This is where I went to do my class.
That is digitally signed.
Well, looky here.
This
is where you go for mobile device management school.
That really is a company-owned laptop. This could be on a.
So I got my certifications for Purebred, which is the mobile credentialing for app iOS, Android, and Windows. Using a YubiKey, I got certified through the DoD to use Purebred.
At King Supers,
all right. Talks about certificates, crypto monitorization. How can I get certified? You actually have to use here too, go through here too, to get to the resources to download those crypto keys and certificates to apply them to government networks. It also tells you that they're ceasing the use of PKI certificates using like the RSA 2048 and SHA 256 on both Nipper and SIPRNet. December 2027, they are moving to how many rounds of encryption is that? RSA 3072. That is not going to be the base, but 4096 is preferred. We're learning a lot of telemetry today about what's changing.
Really was digitally signed by the certificate authority. So as part of your security infrastructure, you would have a certificate.
And it tells you everything, so you can keep up to date on what's new out there. And you can email these folks if you feel led to.
We also have our laptop in the field.
You can find out some more information. So please go here.
Just for this machine.
DoD cybersecurity training, cyber awareness shadows available. Go ahead, Charles, knock it out.
CA certificate, and we know the device
Annual report. No.
We can then compare these two certificates, and we can see that
All
the
right.
device certificate was signed by the certificate authority.
And then here you can get your certs, get your DoD certs.
Now that we've gone
You can
through the
download it.
verification process,
All right.
how do we authorize that
So,
device to have
hey,
access to resources?
Just wanted to show you that.
in our network?
Any questions?
We would do that by using an authorization model. And
All
there
right,
are
so
many
let's go ahead and
different
take 10
authorization
minutes.
models to choose from.
And when we
And
get back,
we listed
let's work
these
some
later
assignments
on
for an
in the
hour.
video
How about that?
series in section
All right, see me.
4.6. We would commonly authorize users and services to have access to certain types of data and applications. The challenge here is, how do you create this relationship in a form that's able to easily scale for tens, hundreds, or even thousands of users? In many environments, we accomplish this by taking the users and services and putting an authorization model right in the middle before you access the data and the applications. These are commonly defined by roles, organizations, attributes, and many other types of characteristics. Let's say that you had no authorization model at all. We would create a series of rights and permissions where the user has rights to access the resource. The problem is that this doesn't scale very well. Let's take an example of somebody in the shipping and receiving department. This is someone who needs access to a large number of systems, a lot of data. Maybe there's tracking information, shipping labels, databases of customers, and we would create separate rights and permissions so that anytime this person logged in, we would need to give them rights to create a shipping label, track a shipment, view monthly shipment reports, access customer data, and perhaps anything else they need for their day-to-day operations. Now, if this is the only person in shipping and receiving, this is a relatively easy process. But what if you're part of a larger organization that has tens or hundreds of people in shipping and receiving? You can see it would be difficult to take every single user account and manually set up rights and permissions for every single resource that they need access to. In this case, there's only 3 resources, but imagine if there were tens or hundreds of resources, you would need to set those up for the tens or hundreds of users. You can see now why this would be very difficult to scale. To be able to scale, we would need to use an authorization model. Sometimes you'll hear this referred to as an abstraction that allows us to separate the users from the information they're trying to access. This greatly streamlines the process of administering these large number of users or large number of resources, and we can support a very, very large infrastructure just with a very simple set of abstractions. Here's how this would work. We'd have the same user in shipping and receiving, and we will add them to a group called shipping and receiving. We set this group up originally so that anybody added to the shipping and receiving group would have access to create a shipping label, track a shipment, view monthly shipment reports, have access to customer contact information, and anything else you would need in shipping and receiving. Now let's add in our tens or hundreds of users. Instead of manually mapping every single user to the individual authorizations they need, we just simply add all of the users to the shipping and receiving group. With this one single addition, we can give tens or hundreds or thousands of users access to the resources they might need, regardless of how many users there are and regardless of how many resources they need to access.
This is a team feeling zen. And these are the Dell PowerEdge servers that make them feel that way. They take care of themselves. So the team can spend less time
As the name implies, a gap analysis is a study of where we are versus where we would like to be. And in the world of IT security, we're constantly performing gap analyses to be able to understand exactly what security is going to be needed in the future. Although this is very simple to explain, it's a relatively complex process to perform the analysis of what's actually going on in your environment and putting together a plan of how to get from where you are to where you're going. As you might imagine, trying to understand every aspect of IT security and how it applies to your organization can be a very involved process, and this is something that commonly takes a number of weeks, months, or even years to compile. As you can imagine, this might involve a number of different people in your organization, and there is an extensive project plan, materials, and data gathering, and anything else that's needed to compile the information about what's happening with security in your environment. Before starting the gap analysis, it's useful to have a baseline. This gives you something to work towards and an idea of where the goals should be for your organization. There are a number of different baselines to choose from, and some of these baselines have been specifically created for certain organizations. For example, your organization may be following a set of baselines from the National Institute of Standards and Technologies. They publish a document called the Special Publication 800-171 Revision 2, and the title of that document is Protecting Controlled Unclassified Information in Non-Federal Systems and Organizations. You might also use a baseline that was created by the International Organization for Standardization and the International Electrotechnical Commission. This is the ISO IEC 27001, or the Information Security Management Systems. And of course, you could create your own baselines based on your specific needs as an organization. These baselines will commonly involve an analysis of the people in your organization and the processes you use for security. When evaluating people, you might want to get a better understanding of their formal experience in information technology security. You might want to understand what kind of training they've received, and you might want to see if they have a knowledge of specific security policies and procedures that you can use in your organization. Even with the right people in place, you'll still want to be sure that you're following the correct policies for IT security. This might start with an evaluation of the existing IT systems and how they relate to your formal policies that have been created in your central security policy documentation. The analysis portion of the gap analysis will begin with a comparison of the existing systems that you have running in your environment and to identify any weaknesses that those systems might have. You can also compare these weaknesses with the most effective processes for understanding how to compensate for those weaknesses. Ultimately, you'll create a detailed analysis where you'll look at very broad categories of security and then break down those broad securities into individual smaller segments. Here's a good example of how you might start with broad understanding of a process and then breaking it down into individual pieces. This is the document 800-171 Revision 2, which is Protecting Controlled Unclassified Information. And this is a table that maps the access control requirements to the security controls that are in place. For example, this page shows access control, where you would want to limit system access to unauthorized users, processes acting on behalf of authorized users and devices. This account management covers a number of different individual security controls. So when we start to break this down, we can look at user registration and deregistration. We need to understand how user access provisioning is handled, understand the management of privileged access rights, a review of the user access rights, and so on. By looking at these broad areas, we can now break down individual security tasks to see how well we're handling the processes and procedures for each of these individual steps. Once we've gathered all of this information for all of our processes, all of our devices, across all of our different locations, we need to create a final document that summarizes everything that we've discovered. We can start with a comparison that looks at the detailed baseline objectives and gives a perspective of where we are today versus where we would like to be with each one of these objectives. Perhaps the more difficult question to answer is how you get from where you are to where you'd like to be. This path to get from where we are to where we'd like to be commonly takes time, it takes money, there may be equipment that we need to purchase, and obviously there's change control so that you can implement these changes in your environment. Once we have all of this information compiled and the plan of how we can get from where we are to where we'd like to be, we can create a final gap analysis report. This report not only includes the information about where we are today, but it also provides that pathway so that we can understand what it's really going to take to move forward into the future. All of the recommendations you have about meeting this baseline will be documented in this gap analysis report. Here's an example of one of the tables that you might include in your gap analysis report. On the left side, I have a series of system requirements, and all of those system requirements were broken into smaller pieces in the detailed part of the report. But we might want to get a much broader understanding about all of our different remote sites and how they are compared to the ultimate baseline that we would like to reach. For example, our organization might have 7 different locations, and we've performed a gap analysis across all of these system requirements for all 7 of those locations. The locations that are relatively close to meeting the baseline, we can mark with a green color. Anything that might be in the midpoint, we can mark as yellow, and locations that need a lot of work to be able to meet our standardized baselines, we'll mark with red. So if we wanted to have the biggest impact on improving our security, we may want to start with the locations and security requirements marked in red, and then move to the ones marked in yellow, and then finally the green. The report obviously will include extensive details about why these colors were used and provide a summary of how we can implement security controls to better meet the goals of these baselines.
Tastes like money. To Oliver, eating here instead of buying a stadium hot dog is like putting away $20. If Oliver sees sandwiches as a saving strategy, Wells Fargo's right behind him. And with their mobile app, tracking his savings is easy. Oops. However you make money work, we can work with that.
This morning calls for sausagey, pancakey, Jimmy Dean griddle cakes.
In many networks, you'll find that once you're through the firewall, the inside of the network is relatively open. People are able to move from system to system without any type of checks or balances. There are relatively few security controls in place, and this not only allows authorized individuals to move anywhere they'd like, but also allows unauthorized individuals and malicious software to do the same. But many security administrators are changing their network to be zero trust. This means that you have to authenticate or prove yourself each time you want to gain access to a particular resource. This applies to every device on the network, every process that's running, and every user on the network. As the name implies, with zero trust, nothing is trusted, and everything is subject to some type of security checks. This means you might be using multi-factor authentication during your login process. You may be encrypting data that's stored and encrypting data as it's traversing the network. There may be additional system permissions or additional firewalls that you're installing. And there are a number of different security policies and different controls that may need to be added to create this zero trust environment. One of the ways that we can start examining and implementing zero trust on our networks is taking our security devices and breaking them into smaller individual components. We commonly refer to this as separate functional planes of operation. So whether it is a physical device, a virtual device, or a security process that's running in the cloud, we can apply these different control planes to every single one of these security controls. Broadly speaking, we can look at these as having 2 different planes of operation. One of them is the data plane. The data plane is the part of the device that is performing the actual security process. So this might be a switch, router, or firewall that's processing frames, packets, and network data in real time. The data plane on these devices is processing any forwarding, network address translation, routing processes, or anything else that helps move data from one part of the network to another. But of course, all of this movement of data needs to have some type of management and control, and we perform that control in the control plane. This is where we manage all of the actions that are occurring in the data plane. This means we may be configuring policies or rules for a device to determine whether data may
All right, as we're coming back from break,
or maybe we're setting up a forwarding
what
policy.
I have on the screen is the DoD approved product list if you guys have never seen it before.
You're looking at a firewall rule or understanding
As asset managers or running systems, you need to be able to know where to find this stuff. So on the cybersecurity, the DISA website, so it's DISA.mil. The link is actually through the DoD website.
Here we have a physical switch, and we want to be able to break out the different planes of operation. Down at the bottom of the switch are all of the different interfaces.
So through cyber.mil, it has documentation library.
And as we've already seen, all of the traffic that we're forwarding all happens on the data plane of the device.
And it has the approved
this
list
needs to have configurations. There needs to be network
of what you can use on the network. It's right there on the front page.
All of those changes would take place in the
So through cyber.mil, there's the approved network. Over here on the left, it talks about the Department of Defense Secure Access File Exchange. They call it SAFE. This is what remote forces or people in remote areas would use to upload information, and you can upload up to 8 gigs in total. So for the Marine Corps, for those that were out on aircraft carriers, we need to exchange information about F-18 aircraft or aircraft, computing data. You could use SAFE, and with a CAT card, you can upload information to the SAFE server. So this is secure. This is a secure way to send files. This basically is FTS, file transfer protocol, FTP secure. And it gives it a code or a hash with it. You send it to whoever is downloading it, and they put in the password, and it allows them to download it. This is actually how most people get their medical records from medical. Medical will upload it in here because you can't send it through the network anymore. Because there's sniffers on the network to make sure there's no PII in emails. They'll send it through DoD Safe, send it to themselves, and then when they get home, they use the key, download it. Then, if you need to get DoD certs, these are zip files through. Look at this, the Certification Authority, the CA. So, as a PKI manager, you can go through here, and it tells you how to download, request certificates, and you have to go through the class. So before you can even do this, there's a class you have to go through.
This particular network. And once you have all of this information in place, we can now start creating what's called a policy-driven access control that examines all of these individual data points, puts them all together, and then decides.
It has a white letter on how to become an administrator for PKI, PKE.
The person trying to identify themselves is really that.
So here's your rootkit.
Another good way
The Trusted Management Root CA tells you everything you need to do. Let's see if it's in there. It might have switched some things around. Yep, there you go. Right there. That's what a roadblock is put in there. You need a CAT card to look at it. Or look at the public page. So now it's limited information. Yep, sends me right back to the main page. So yeah, there you go. But yeah, look around the site. Get familiar with it.
Untrusted network.
Good
We're
stuff.
trying to connect to a trusted network, or maybe it's an internal network or external network. And if you wanted to have even more granularity, you could create separate VPN connections or separate groups of different departments within your organization. This allows you to now start setting rules on what zone has access to all of the other zones. For example, you might want to have a rule that automatically denies access if someone is coming from an untrusted zone and trying to communicate to a device that's in a trusted zone. We can also use these zones to create an implicit trust. For example, if someone is in our corporate offices, they might be in a trusted zone. This user in the trusted zone may be accessing data on a database server that's in our data center, and the data center exists in the internal zone. This might allow us to create some policies that says if anyone's communicating from the trusted zone to the internal zone, that portion of the communication is implicitly trusted.
Future-proof your home and garden with AARP today. Harvest the rewards for years to come. That's why the younger you are, the more you need AARP.
To be able to set these policies and procedures along this pathway, we need to have something in place that allows us to create an enforcement of these policies. This is our policy enforcement point, and any subjects and systems that are communicating through this network will be subject
If you are
to
back,
evaluation by
camera
the
zone.
policy enforcement point. These subjects and systems commonly are end users, their individual processes running on a system, or they may be applications that are in use. You can think of this policy enforcement point as a gatekeeper. All of the traffic traversing the network must pass through the policy enforcement point so that we can make decisions on whether we would like to allow or disallow this traffic. And although this policy enforcement point is shown as a very broad abstraction in this diagram, you can think of this as multiple devices working together to be able to provide identification of the users and the traffic. The policy enforcement point doesn't provide the decision on whether traffic should be allowed or disallowed. Instead, it gathers all of the information about the traffic and provides that to a policy decision point. This policy decision point is responsible for examining the authentication and making a decision on whether that should be allowed on the network. Your policy engine is looking at all of the requests that are coming through. It examines the request and compares it to a set of predefined security policies, and then makes a decision on whether that is granted, denied, or revoked. The policy administrator's job is to take that decision and provide that information to the policy enforcement point. There may be access tokens or credentials that are created as a result of these policy decisions, and all of those credentials are then sent to the policy enforcement point using this policy administrator. Now we can put all of this together to create a single zero trust model, which starts with our subjects and systems communicating from an untrusted zone over the data plane and communicating through the policy enforcement point. If there is a policy enforcement that needs to take place, this enforcement point will provide that to the policy administrator, which then communicates to the policy engine to make the decision about whether this traffic is allowed. That result is then passed down to the policy administrator, which provides that to the policy enforcement point. And if this traffic is allowed, the policy enforcement point then provides access to this trusted zone and ultimately the enterprise resource requested by the subjects or the systems. IT security professionals not only need to be proficient in digital security, they also need to have a knowledge of physical security. One common physical security method is to have a barricade or a bollard that prevents people from accessing certain areas of a physical area. These are often used to channel people through a certain access point. And it's common to have these bollards set up so that individual people can pass through, but prevent any cars, trucks, or other vehicles from getting into that area. These barricades can also be a security notice, especially if they're brightly colored, letting everyone know that this is a high security area. We often see these installed as concrete barriers or bollards, but you can also create barricades in other ways. For example, you may have water around a particular building and require people to go over a bridge to gain access to that facility. When you enter or exit a building, there's also a great deal of physical security, especially through using something like an access control vestibule. This is one where there is a room you must pass through to be able to gain access to the rest of the building. This might be a room where all the doors are normally unlocked, and if you open one of those doors, no one else can enter the room while that door is unlocked. Or this may have higher security where all of the doors to the room are locked, and when you badge in or unlock the first door, all of the other doors remain locked and cannot be unlocked while that individual door is open. Or this may be the case where one of the doors of the room is always locked and the other door is unlocked. And when one door is open, the other door cannot be unlocked. Regardless of the configuration, these access control vestibules are designed to allow or control access through a particular area. They may be a very small area where only one person can traverse at a time, or maybe it's a controlled group of people where you're evaluating their identification and then allowing them through the room. Here's an example of one of the doors to an access control vestibule. This one has a card reader or biometric reader on the outside that could allow you access to the room, at which point you would check in with security, provide authentication, and they may give you a pass or a card to allow you access to the rest of the facility. This is very common for very large data centers or for areas where you just need additional security to make sure that only the appropriate individuals are able to pass through that particular area. Another type of physical security control is a fence. This is one that's relatively common, and it's something that you can easily see is installed. In this example, you can see the fence going across the front of this facility. Because this is so obvious, it may not be the exact security control you're looking for, but it does provide a very good way to prevent access through this area. This may be a transparent fence where you're able to see what's on the other side, or you may design an opaque fence where people can't see what's on the other side. From a security perspective, we would like these fences to be very robust. We don't want someone to be able to bend the fence or knock down part of it to gain access to the area. And in very secure areas, you might want to make it more difficult for someone to gain access over the fence. This might include a very high fence, or you might have razor wire across the top just to prevent anyone from gaining access by going over the fence. Some physical security techniques require someone to stand in an area and monitor a particular location to watch for certain security events to occur. But you might be able to make this a bit more efficient by using a camera. When you're putting a lot of cameras together that's for your own use, sometimes you'll see this referred to as CCTV, or the closed circuit television. These cameras are becoming increasingly more intelligent, so they have things built in such as motion detection, so they can alarm or alert you if someone happens to walk through an area, and in some cases can provide very detailed object detection and be able to read someone's face or be able to read the license tag on a vehicle. Most organizations will have multiple cameras. These are all networked together and will send all of their video back to one single storage point so that you're able to record this information from every camera over time.
A meal that's dip-tacular. Ciabatta dippers are back. It just feels good at Panera.
But sometimes you need more than a camera or some type of automated security. And if that's the case, you may want to add a security guard for physical protection for anything that may happen in a particular area. This is someone who may sit at a front desk and validate that anyone walking into the building is either an employee or someone who is allowed in as a guest by an existing employee. You'll often see security guards working as two or more people simultaneously to provide two-person integrity or control. This means that one security guard would not be able to circumvent the existing security policy because there's always someone else there to provide checks and balances. And in almost every organization, you're required to wear an identification badge. This is a badge that may be on a lanyard or it may be attached to a jacket or coat, and it will have a picture, a name, and other details about the person who has that identification badge. This is a badge that you would wear and have visible to everyone at all times so they can easily see at a glance that you're allowed to be in a particular area of the building. These are often integrated with the electronic locks that we might have outdoors, so every time you badge into a room, you can use your identification card, and all of that information is logged to a central database. One way to prevent an attacker from gaining access to a building through a dark area is to simply illuminate that particular area with lighting. More light usually means more security, because someone trying to get into your building who is unauthorized will probably want to do this outside the view of someone else. Sometimes you can use cameras that have infrared technology to be able to see better in dark areas, but nothing is more secure than having a well-lit area.
All right, these are your hours as of 6 p.m. yesterday. 6 p.m. yesterday.
One that can illuminate the entire areas, and you want to be sure that the lighting angles are important, especially if you're using cameras to capture facial recognition. In a parking lot, for instance, you may have lights to be able to illuminate
6 p.m. yesterday.
in the parking lot, and then have cameras that are able to monitor that parking lot 24 hours a day.
So we're on day 6. This is where we should be.
As we mentioned, we might have cameras using infrared.
At the end of the day
technology
today.
that may be happening in the dark. These are devices that can detect infrared radiation.
So at the end of the day today, you got to be over 38.4.
Have lights to be able to see what's happening.
Minimum.
It's also common to see this infrared technology being used in things like motion detectors, where you're not necessarily looking for video, you're simply looking to see if there's something that may be moving in a particular area. In some organizations, you might even use pressure sensors. So when somebody moves across
Here's the total program hours over here.
It can alert or alarm you.
So this is total program hours up to week 9. Where you're at now, as of yesterday, at 6.
Relatively limited area. But if you have a very large area that you would like to monitor, you might want to use microwave technologies. These are designed to detect movement over a much larger area.
So if you're close to 324, you're doing darn good.
And perhaps even more advanced.
So you have to be past these numbers by test day next week at 6 p.m. on test day. On test day next week.
And can even be used to provide collision detection, especially in something like a parking lot or a loading zone.
Cannot be below 280 gig. And can't. Yeah, so you guys got it.
As an IT security professional, you'll spend a lot of time trying to prevent attackers from gaining access to your systems. But you'll also be able to use your knowledge and techniques of security to create deception and disruption to those same attackers. One way to provide this deception is by using a honeypot. A honeypot is a way to attract attackers to your system and be able to keep them involved in these systems so that you can see what type of security techniques they're trying to use against you. In most of these cases, of course, the attacker is actually an automated process. And what you're trying to do is to see what type of automation is being used and what type of systems are they trying to attack. These honeypots are a virtual world that effectively attracts these automated systems or attackers, and they spend all of their time trying to identify or attack systems which in reality are not part of your production processes. If you wanted to build your own honeypot and virtual world, you can do that using a number of commercial and open source software packages. This also creates a bit of a race between you creating virtual worlds that in most cases are not production systems and the attackers that are trying to discern whether these systems are actual systems or if they are trapped inside of a honeypot. As the attackers get better with identifying a honeypot, we increase the complexity and intelligence of our honeypots to make them that much more realistic. It's very common, in fact, to combine a number of these virtualized honeypots into much larger infrastructures that we call honeynets. These honeynets may consist of workstations, servers, routers, firewalls, and anything else to make the entire infrastructure look a little bit more real to the attacker. Once you combine all of these smaller honeypots into one much larger honeynet, you've now created a much more believable environment and hopefully one that will keep the attackers very busy. If you'd like to learn more about the techniques and technologies we're using today to create these honeypots and honeynets, you can visit projecthoneypot.org. We can even go down to the file level and create honey files. These are files that have fake information, or they may be files that appear to be very important or contain sensitive information. For example, you might have a honey file called passwords.txt, which of course does not actually contain the passwords to your systems. But the attacker doesn't know that. They may find this to be a very attractive file, spend a lot of time going through the information contained within that honey file. In your normal production network, no one should be accessing these honey files. So if someone does gain access to the file and opens or views the information, you may want to have alerts or alarms sent back to a management station so that you know someone is poking around in the honey files who probably should not be there. And another type of data that might help you identify issues with data that's being released into the public would be a honey token. Honey tokens are a bit of traceable data that you would add to your honey net. So if that information is copied and distributed, you know exactly where it came from. For example, you might put API credentials out on a public cloud share to see who may come by and grab those credentials. Of course, these API credentials are not actual usable API credentials. You've simply made them up and put them into a file that is then accessed by the attacker. Or you might have a file that contains a number of fake email addresses. Because these email addresses are not used by anyone, you can constantly monitor for those addresses to appear somewhere else on the internet. And if they do, you can see exactly who posted it, which might give you information about who may be attacking your network. And of course, these hunting tokens can be any type of data that you might falsify and put into an area for an attacker to find. This could be database records, browser cookies, pixels on a web page, or anything else that you could track if it happens to be posted somewhere else on the internet.
Build a website you love with Wix.